Scientists at CERN recently made a world-shattering discovery that could open up the doors to new, never-dreamed-of technologies that no one thought were possible. The scientific community is about to be turned on its head as researchers at the CERN Large Hadron Collider in Europe scramble to check their work in an experiment that has apparently broken the laws of modern physics. Scientists working there have found evidence that suggests subatomic neutrino particles may have traveled faster than the speed of light within the particle collider, which is 17 miles or 27 kilometers in length. There's just one catch: nothing can go faster than the speed of light. So, what is the meaning of this mind-blowing discovery, and how does it affect the world of physics? Stay with us till the end of this video to find all about this bizarre and terrifying faster-than-light neutrino anomaly. Now, let's get right into the video. Albert Einstein, the father of modern physics, based his special theory of relativity on the principle that no object can travel faster than the speed of light, which is 299,792,458 meters per second. In other words, if the CERN experiment turns out to be correct, Einstein's theories, which have opened the way for innumerable technological achievements over the last century, may simply be scraping the surface of a much more intricate physical nature of our universe. Quantum physics, the study of the fundamental particles that make up everything in the universe, has advanced some fascinating new ideas in recent decades. The goal of CERN's experiments is to smash particles at high speeds in an attempt to discover the Higgs boson, commonly known as the God particle. Currently, this is thought to be the smallest conceivable particle. Since particles of the same polarity should normally repel one another, it is hypothesized that this particle may provide insight into the nature of the strong force, the most powerful attracting force at the subatomic level. Think magnets repelling one another. Scientists have made tremendous progress in several areas while searching for the Higgs boson particle. For a whole 1,000 seconds, for instance, scientists at CERN managed to contain antimatter. The researchers who made the discovery are currently trying to get their findings verified by other scientists. In question, scientists measured a neutrino beam moving 60 nanoseconds faster than the speed of light, with only a 10 nanosecond margin of error. Some theoretical physicists on the fringe have caused a stir with outlandish ideas that could help explain the CERN discovery. A few years ago, Nassim Haramein published a paper proposing a whole new theory of quantum physics, which sent shockwaves across the scientific community. At the subatomic level, he says, protons function more like black holes than like particles. He has labeled this hypothesis as the Schwarzschild proton theory. According to his theory, the protons that make up the strong force have the gravitational pull of minuscule black holes. Like the planets and stars in our galaxy orbiting around a gigantic central black hole, the electrons and other quantum particles observed at the subatomic level orbit a central point. In essence, Haramein claims that the Higgs boson does not exist. Despite extensive testing, CERN scientists are no closer to discovering the elusive Higgs boson and have gone on record saying that it is possible the particle does not exist. Haramein's ideas have been dismissed by the majority of the physics community, but recent discoveries at CERN suggest that our understanding of the physical nature of reality may need to be revised. The most important finding in physics in the last 50 years, if confirmed, would be the elusive, almost massless subatomic particles known as neutrinos appear to travel at a speed slightly faster than the speed of light. If this were the case, it would disprove Einstein's special relativity, which states that no object can move faster than the speed of light. The outcome would be so groundbreaking, in fact, that it would be regarded with widespread suspicion. This information was gathered by the Oscillation Project with emulsion T-racking apparatus, a particle detector that weighs 1,300 metric tons. CERN, the European Particle Physics Laboratory, is located in Geneva, Switzerland, and fires neutrinos through the Earth to Opera, which is hidden in the Italian underground at the Gran Sasso National Laboratory. Particles have relatively weak interactions with matter, thus they pass right through the ground and just a small fraction of them shower the detector's substance with particles. Over the course of 3 years, Opera scientists measured the arrival times of nearly 16,000 neutrinos that had originated at CERN. They discovered that neutrinos, on average, traveled the 730 kilometers in around 2.43 milliseconds faster than expected if they were traveling at the speed of light. The main question is whether or not the Opera team has observed particles traveling faster than light, or whether they have been fooled by an undiscovered systematic error in their experiment that is making the period look artificially short. After a 3.5-year refurbishment, the particle accelerator Large Hadron Collider on the border of France and Switzerland is ready for nuclear scientists to blast new frontiers in quantum physics and crack secrets concealed in so-called dark matter. Since its beginning in 1998, construction of the Large Hadron Collider has spanned a full decade, accelerating protons and ions to extremely high speeds and smashing them together in a 27-kilometer-long subterranean circular tube allows scientists to test the ideas of particle physics. The Higgs boson, a particle thought to give matter to its mass, was found in 2012. Thanks to the LHC, this led to Peter Higgs and François Englert receiving the Nobel Prize in Physics in 2013. The LHC was shut down at the end of 2018 for its third upgrade, and now scientists at CERN, the European Organization for Nuclear Research, are ready to begin intensive research with the upgraded machine. The following update is not expected until 2026. The phaser and scattering and neutrino detectors are two of the newer instruments added to the LHC as part of the latest refurbishment. Researchers can use these to search for neutrinos and a form of dark matter called light dark matter. There's a lot of difficulty in detecting neutrinos because they are chargeless, ultralight, subatomic particles. Since their direct detection in the LHC, scientists have been able to examine the properties of these previously little studied particles. More than 85% of the mass in the cosmos is assumed to be dark matter, but its nature has so far evaded scientists. Waiting for dark matter to collide with regular matter particles is the standard method for attempting to discover it. Such encounters would cause matter particles to recoil, allowing for the detection of dark matter. Heavy dark matter, as opposed to light dark matter, has been the main target of these studies. Assuming that dark matter particles have masses less than protons, these hypothetical particles would not have a recoil large enough to be detected by most tests. The new detectors at CERN are not designed to detect dark matter entirely, but rather the light dark matter particles that researchers at CERN hope to create through collisions at the LHC. Even the LHC's underlying engineering has been radically revised by CERN. Increased injector output and overall detector sensitivity were the results. As a result of upgrades to the injectors used to speed up particles before they are injected into the LHC, higher energy can be produced. This means that the previous world record for proton collision energy of 13 tera-electron volts has been broken, making 13.6 tera-electron volts the new limit. The increased potential for particle creation due to higher energy collisions is facilitated by the extra 0.6 TeV. The improved detectors make it possible to keep tabs on the more powerful and frequent encounters. With the enhancement, the LHC can store more data. Scientists won't just be able to look for candidates of dark matter, they'll also be able to look into the features of quark-gluon plasma, or QGP, a unique state of matter thought to have existed for only 10 microseconds after the Big Bang. Scientists will be able to test whether QGP, now observed to be a frictionless liquid, turns gas-like at greater temperatures thanks to the higher collision energies in the LHC. The question of whether or not many Higgs bosons exist will also be explored. They will also keep digging into the universe's matter-antimatter symmetry in search of evidence that contradicts the standard model. The best explanation we have for describing the universe's fundamental constituents at the moment. CERN is branching out into fields unrelated to particle physics. Specifically, it is working with the pharmaceutical and healthcare sectors to construct hadron therapy centers around Europe. When compared to conventional radiation therapies, hadron therapy is a more favorable option for treating cancer. The researchers at CERN intend to keep digging into a wide variety of fields, including electronics, manufacturing, and more. To further improve its data collection capabilities and infrastructure, the company is investigating quantum technologies. By using quantum physics, quantum technologies are creating smaller and faster computers. That pretty much wraps this video up, guys. Thanks for watching. So, what are your thoughts about this shocking discovery at CERN? Share with us in the comments below. Make sure you subscribe to this channel with a bell notification if you enjoy watching our content. We upload some awesome stuff here which you will most certainly enjoy. Hit a like on this video and leave a comment below. See you guys in the next one.